Okay, you are welcome back to Introductory Mathematical Analysis A. We are still in chapter 4, and also still in 4.2 and 4.3. Alright, so we are still in logarithm function in 4.2 and 4.3. Alright, we started this in the previous videos, and I want you to go over the videos if you have not watch the previous one before this one. Okay, so again we recall that this is an exponential function. Recall that this is an exponential function, and the inverse of this exponential function is this logarithm function. So again, this sign is for inverse. Okay, so inverse of an exponential function is the logarithm function. So, and we mentioned that if we have an expression like this, b raised to power x equals to y, you can change this into logarithm function by writing log. This base is the same thing as the base. Now, the one on the right hand side will become the log, while the one which is the exponent of the power becomes the right hand side of the log function. Okay, so you can change this from here, and of course you can also change from log to exponential function. Please take note of that. All right, now we want to take note of some rules of logarithm function. Some rules of logarithm function. Okay, rule number 1. If we have log to base b of log m to base b, and then we are adding them to log n to base b, don't forget this log has the same base. Okay, so you cannot do the operation without being in the same base. Okay, this to base b, this to base b, and the operation is addition. Okay, then this m and n will be multiplication. Okay, so log m to base b plus log n to base b will give us log b m multiplied by n. Okay, all right. So an example is when we have log 7x plus log 7(3). Okay, this will simply give us log 7, the same base, 3 multiplied by x, which is log 7(3x). Okay, log 7(3x). All right. Take note that they must be the same base, and the operation connecting them is addition. So you cannot have something like this, you cannot have something like this, you cannot have something like this to give us this. Okay, you may want to write it this way. Okay, you can't have something like that. It's not possible. This is not part of the rule, so you cannot have something like that. Okay, rule number 2. Now if it is negative in between and not addition, negative will give us division. Negative will give us division. So if you have log 5, then minus log 5, 5. Okay, the same base. So now we have log to base 5 because they are the same base. This one comes first, so that is the one that will be at the numerator, and then this one will be at the denominator. So negative operation between the logs gives us division. Please take note of that. Now, rule number 3 says when we have log to base b of m, and that m, log of m to base b, log m to base b, and that m is as an exponent. Okay, we can bring down this exponent, but when you bring down this exponent, must be at the back of the log. So it becomes r log b, log mb. Okay, it becomes log r multiplied by log of m to base b. So you bring down the exponent. Okay, please take note of that. You bring down the exponent, then you write the log. All right. So rule number 4, log of 1 to base b gives us 0. So any base, whatever base we have in the log, as soon as it is log of 1, then it gives us 0. Okay, let's see this clearly by changing this to exponential function. Let's try to change this to exponential function. If we change this to exponential function, what are we going to get? We are going to be getting b, the same base, but the right hand side here give us the exponent, and then this one give us the right hand side there. Now you see clearly now that b raised to power 0 is 1. That is the law one of the rules in exponential function. One of the rules in exponential function. So that's why log 1 to any base gives you 0. Log 1 to any base gives you 0. So any base, either base 99, as long as it is log 1x should give you 0. Okay, so log 1 200 to any base gives you 0. Log 1 2 gives you 0. Okay, log 1 to any base gives you 0. Okay, take note of that. Now rule number 5 is that log of b to base b. So whenever the log and the base are the same, then we get 1. Okay, log and the base. So when we have log 2 to base 2 gives us 1. Log 10 to base 10 gives us 1. Log 5 to base 5 gives us 1. So whenever we have the log and the base to be the same number, then we get 1. Please take note of that. Now rule number 5. In rule number 5, whenever we have the log, we can change it into this form. So whenever we have log bm, we can change this into log m over log b. Okay, you can change this to log m over log b. Now they are not no base for any one of them now. I mean, no base for this one. We don't have any base for this. We don't have base for this. But previously we mentioned that if we don't have any base, then it could be, we could just assume base 10. Okay, so I can say log 10m over log 10b. I can write like that. Okay, that is fine. But if I don't want to use this 10, I want to use another base, I can also use another base. Okay, and more importantly, I'm interested in using base e. Don't forget, that is very important to us in mathematics. So if I use base e, I will say log em over log eb. Okay. Now, if I use base e for both of them, so you cannot use e here and use 10 here. No. You must use the same base for both of them. All right. Now, since this is log e now, this becomes ln. Ln m all over ln of b. So this becomes ln m over ln b. Okay, because it's now to is now in base e. Is now in base e. So we can write it as ln m over ln b. Okay, that's very important. So when we have log 2, 3, this is the same thing as ln 3 over ln 2. Okay, this is simply the same. Okay, all right, please take note of that. All right, rule number 7. So whenever we have log to base b, and we also have an exponential function that has the base, the same base with the log, then of course, if you write this like this, let me write it out. In one of the rules says we can bring down this x, so it becomes this. And log b to base b is 1. So this gives us x. All right. So we see that gives us x. But this base, the base of the log, must be the base of the exponential function. The base of the log must be the base of the exponential function for us to have that. Okay. Okay, let's have this. If we say log e and e raised to power x, okay, this also is 1 because the base of the log is e and the base of the exponential function is also e. Alright, this also follows the same thing. Don't forget log and exponential function, they are inverse function. So when we have, this is now, the whole of this is exponential function. But the exponent is a log, which has the same base with this one. So that's why it also gives us x. It also gives us x. Okay, so when we have e into ln of x, that also gives us x. Okay, that is very important. Please take note of that. Take note of that. That is very important.